On the evening of August 8, 2024, the government of Japan did something it had never done before in its history. After a magnitude 7.1 earthquake struck off the coast of Kyushu that afternoon, a committee of the country's top seismologists convened an emergency evaluation, and hours later, the Japan Meteorological Agency issued an alert that had existed on paper for years but had never once been used: a Nankai Trough Megaquake Advisory. An official government statement that the probability of a magnitude 8 or 9 earthquake on the most feared fault in Japan had temporarily increased. For 1 week, a nation of 125 million people lived under that advisory. Coastal towns reviewed evacuation routes, some beaches and festivals closed, store shelves emptied of water and emergency supplies. And then, after 7 days with no further escalation, the advisory was lifted and the world's attention moved on. But the reason that alert exists at all did not move on, because it is anchored to the seafloor south of Japan, where the most heavily monitored fault on this planet has been doing something in the darkness that the instruments were built specifically to catch. Cabled sensor networks laid across the seabed and observatories cemented into boreholes drilled directly into the fault itself have been recording the Nankai Trough moving slowly, silently, in episodes in exactly the zone that generates tsunamis, on a fault that has ruptured on schedule every 100 to 150 years for 13 centuries, and whose last rupture is now 80 years in the past. The official estimate from Japan's Earthquake Research Committee gives this fault a 70 to 80% chance of producing a magnitude 8 to 9 earthquake within the next 30 years, and the government's own worst-case scenario for that event projects casualties. That would make it the deadliest natural disaster in the modern history of any developed nation. Today, the full story of what Japan is recording beneath the seafloor, why this one fault carries the most complete earthquake diary on Earth, what the first ever advisory really meant, and where the honest line sits between vigilance and fear. No guessing, no dramatizing, just the facts, the science, and the real stakes. A quick word before we descend. Tell me in the comments where you are watching from, and if you have ever lived in or visited Japan, whether you have felt the ground move there, because this episode is about the country that has taught the rest of the world nearly everything it knows about living with earthquakes, and first-hand accounts always deepen these conversations. If you want to follow this fault as its story develops, subscribing keeps you connected. This channel returns to Japan again and again for good reason. Now, south of Honshu, to the trough. Start with the diary, because no fault on Earth has anything like it. The Nankai Trough is the deep ocean trench running along Japan's southern coast, where the Philippine sea plate dives beneath the islands of Shikoku, Kyushu, and central Honshu. And because Japanese civilization has kept written records for well over a millennium, temple archives, court chronicles, village accounts of shaking and waves, scientists have been able to reconstruct this fault's rupture history with a completeness that exists nowhere else on the planet. The list reads like a heartbeat across 13 centuries. The year 684, the year 887, 1096, 1361, 1498, 1605, 1707, 1854, 1944, and 1946. 9 or more great rupture episodes, arriving at intervals of roughly 90 to 150 years, documented continuously since before the Vikings reached England. No gap in the record, no skipped beats that anyone can find. And inside that diary are details that shape everything about how Japan prepares today. The fault does not always rupture all at once. It is divided into segments, an eastern side and a western side, and history shows they sometimes fail together and sometimes in pairs, separated by a delay. In 1854, the eastern segment ruptured in a magnitude 8 class earthquake, and the western segment followed 32 hours later. In 1944, in the middle of the war, the eastern segment broke, magnitude 8.1, and the western segment held on for 2 more years before rupturing in 1946. That twin rupture behavior is not trivia. It is the entire reason the advisory system exists, because history says that when one part of this fault goes, the clock on the rest of it can be measured in hours or in months. And one more entry deserves its own sentence. The 1707 Hoei earthquake, believed to have ruptured nearly the entire trough at once, one of the largest earthquakes in Japanese history, was followed 49 days later by the last eruption of Mount Fuji, an association scientists still study, and a reminder that in Japan the great systems are not always polite enough to take turns. Now to the arithmetic every Japanese schoolchild eventually does. The last ruptures were 1944 and 1946. It is now 2026. 80 years and counting, inside a rhythm that has averaged roughly a century, on a fault that has never in 1,300 years failed to keep its appointment. So what would the next appointment look like? Here the numbers must be handled with complete honesty, because they are the heaviest in this entire field. The Japanese government's official damage assessments for a worst-case Nankai megaquake, a magnitude 9 rupturing the full trough at the worst time of day, project shaking at the highest intensity levels across a corridor holding tens of millions of people, and a tsunami that arrives with almost no time at all. This is the detail that separates Nankai from nearly every other scenario on Earth. The fault lies close to shore. In the government's modeling, the first waves reach parts of the coastline of Shizuoka, Wakayama, and Kochi prefectures within minutes of the shaking. In some communities, as little as 2 to 3 minutes, with maximum wave heights in the most exposed bays of Shikoku modeled at over 30 meters, 100 feet of ocean. The most recent official casualty estimate for the worst case, updated in 2025, is on the order of 300,000 deaths, the overwhelming majority from the tsunami, with economic losses projected in the range of $2 trillion, numbers that would constitute the greatest disaster to strike an industrialized nation in modern history. Those figures are not this channel being dramatic. They are the Japanese government's own published planning basis, and Japan publishes them deliberately, precisely because it learned long ago that a population told the truth prepares, and a population protected from the truth drowns. It must also be said immediately that the same reports show what preparation buys. Their modeling finds that rapid evacuation, the difference between residents moving within minutes versus waiting, cuts the projected tsunami deaths by up to 80%. The entire gap between the worst case and a survivable catastrophe is, in Japan's own arithmetic, human behavior in the first 10 minutes. Which brings us to the seafloor and to what is actually being recorded down there. After the 2011 Tohoku catastrophe on Japan's other Great Trench, the lesson was seared in: the ocean is where the warning lives, and Japan proceeded to do something no nation had ever done. It wired its most dangerous fault directly. Today, the Nankai Trough is covered by DONET, a network of cabled observatories resting on the seabed directly above the rupture zone, pressure sensors, seismometers, tsunami meters, streaming data to shore in real time through fiber optic cables, sensors that would feel a tsunami pass over them and report it minutes before it reached the coast. A new sister network, filling the remaining gap off Kyushu in the west, has been going into the water through the mid-2020s, closing the last blind spot. And Japan went further than the seabed surface. The scientific drilling vessel Chikyu, a ship built largely for this one fault, spent years boring holes kilometers into the trough's accretionary wedge, the wedge of scraped-up sediment above the fault, and cementing permanent observatories into the boreholes, instruments living inside the fault zone itself, measuring the pressure of the water in the rock pores, which is the most sensitive strain gauge nature allows. And those borehole instruments caught something remarkable. The shallow end of the Nankai Fault, the part nearest the trench, the part that moves the seafloor and makes the tsunami, is not simply locked and silent. It slips slowly. In recurring episodes, lasting days to weeks, returning roughly every year or two, each one releasing energy quietly without shaking. Exactly the phenomenon this channel explored in our episode on the strange tremors beneath America's west coast. If you saw that episode, you already know the science, slow slip events, and tremor, the hidden slow motion earthquakes discovered only this century. What Japan has done is take that discovery operational. The borehole and seafloor networks now track Nankai's slow slip episodes as they happen, mapping which patches of the fault are creeping and which are holding, and the published results carry a finding that scientists describe with careful, deliberate language. The slow slip is occurring in the shallow tsunami generating zone. It accounts for a real fraction of the plate motion there, and every episode redraws the map of where the fault is storing strain versus quietly spending it. In other words, the title of this video is not a tease. Japan is, in the most literal sense, recording movement on the deadliest fault it has beneath the seafloor, between the great earthquakes, and no generation of scientists before this one could see it at all. The machine that made those borehole observatories possible deserves its own minute because it is one of the most remarkable vessels ever built, and most people have never heard its name. The Chikyu, meaning Earth, is a Japanese scientific drilling ship the length of 2 football fields, with a derrick towering 30 stories above the waterline, purpose-built with one headline: ambition to drill deeper into an active earthquake fault than humanity had ever gone, and Nankai was the fault it was built for. Over repeated expeditions, Chikyu's drill strings have punched kilometers beneath the seabed south of the Kii Peninsula, straight down through the accretionary wedge and into the fault structures themselves, recovering cores of the actual rock that will host the next magnitude 9, gouged, polished, clay-lined surfaces that scientists can hold in their hands and test in laboratories, asking the most direct questions in the field. How strong is this material? How hot does it run? What does it do when it slips? Some of those cores rewrote assumptions, revealing that even the shallow, supposedly gentle part of the fault had slipped fast and frictionally hot in. The past, meaning the tsunami-making zone near the trench, can participate violently in a rupture, a finding that fed directly into the government's decision to plan for 30-meter waves. And when the drilling was done, the holes were not abandoned. They were furnished, packed with the sensor strings we discussed, sealed and wired into the Seafloor network, converting each borehole into a permanent nerve ending inside the fault. The ship even attempted the ultimate version of the goal, drilling toward the deep, locked zone itself, 5 kilometers and more below the seabed, a technical Everest that storms, currents, and the sheer hostility of the wedge ultimately cut short. Even the failure was informative. The fault guards its deepest secrets, and Japan responded by surrounding it with instruments instead. One more decoding is essential before we go further, because when the Nankai earthquake comes, the world's news coverage will be dominated by a number most viewers outside Japan misread. Japan does not primarily describe earthquakes to its public by magnitude. It uses Shindo, the seismic intensity scale, running from 0 to 7, and unlike magnitude, which describes the earthquake's total energy at its source, Shindo describes the shaking at your location, which is the number that actually decides whether your house stands. A single earthquake has 1 magnitude and thousands of Shindo values, strongest near the fault, fading with distance and soil. The scale's upper end is calibrated to consequences. Shindo 5 means furniture moves and unsecured objects fall. Shindo 6 means it is difficult to remain standing and poorly built structures fail. Shindo 7, the ceiling of the scale, means it is impossible to stand. Buildings of older construction collapse in numbers and the ground itself may deform. Shindo 7 has been recorded only a handful of times since the scale's modern form: Kobe in 1995, Tohoku in 2011, Kumamoto in 2016, Noto in 2024. The government's Nankai scenario maps project Shindo 7 along swaths of the Pacific coastline, and Shindo 6 across an enormous corridor including some of the country's greatest cities. When that day comes and you see the map on the news, you will now be able to read it the way Japan does, not as one number, but as a landscape of consequences, and you will understand why the drills, the retrofits, and the towers were never optional. Now, the honest engine room of this story, what that monitoring can and cannot do, and what the first ever advisory really was. The advisory system rests on one solid statistical foundation: earthquakes cluster. A large earthquake near a great fault genuinely does raise temporarily the probability that the great fault fails. Soon after, history shows it. The 1854 32-hour pair shows it. The global statistics show it. So when the magnitude 7.1 struck the Huguenota Sea in August 2024, right at the western edge of the Nankai zone, the committee's calculation was straightforward and honest. The baseline odds of the megaquake on any given week are small. After magnitude 7 next door, they become several times larger for a while, still small in absolute terms. A few chances in 1,000 rather than a fraction of 1, but large enough, multiplied by 300,000 potential casualties, to justify telling the nation to check its evacuation routes and top up its water. That is all the advisory claimed, and Japan was scrupulously clear about it. Not a prediction, not a countdown. A temporary tilt of the odds announced, openly, with a defined end. It is worth remembering what that week actually looked like on the ground, because it was a live portrait of a society negotiating with probability. In the coastal prefectures, facing the trough, municipal loudspeakers reviewed evacuation procedures. Some towns in Kochi and Wakayama closed beaches at the height of summer, and a number of communities canceled fireworks festivals rather than gather thousands of people on exposed waterfronts. Supermarkets and hardware stores across western Japan sold out of bottled water, portable toilets, and emergency rice, to the point that the government publicly asked citizens to buy calmly. Some hotels in seaside resort areas reported waves of cancellations in the middle of peak season, a real economic cost, absorbed knowingly. The high-speed trains kept running, but some slowed on coastal segments as an added margin. And through all of it, officials repeated the same carefully balanced sentence at every briefing: the probability is elevated. It remains low in absolute terms. Do not panic. Do prepare. Foreign observers watching that week split into 2 camps: those who saw an overreaction to a few chances in 1,000, and those who understood they were watching the world's first attempt to operationalize earthquake probability at national scale, imperfect, costly, and decades ahead of anyone else. When the week ended quietly, Japan did not declare the advisory a mistake. It declared it a rehearsal, audited what worked and what caused confusion, revised the communication guidelines, and folded the lessons back into the system, which is precisely what you do with a fire drill. And the system has been tested by smaller events since. Further shocks in the same Huguenota zone have triggered evaluation meetings that concluded without advisories, and that too is the system functioning. Evaluating, deciding, standing down. Here is the equally honest other half. Some respected seismologists question the entire framework, and this channel will not hide them. Critics point out that the famous 70 to 80% figure rests partly on a time-predictable model, the idea that faults recharge on a schedule, that is weaker science than it sounds, and that if you calculate Nankai's odds, the way Japan calculates every other faults, the number comes out meaningfully lower. Others worry the advisory system risks crying wolf, spending public trust on alarms that will, by mathematical design, almost always be followed by nothing. These are serious arguments made by serious people, and the counter-argument is just as serious, that the 13th century diary is real regardless of which model you prefer. That 80 years of silence on a fault with a 100-year rhythm narrows the argument every single year, and that after Tohoku, which exceeded the official expectations and killed nearly 20,000 people, Japan decided it would rather be criticized for caution than mourned for silence. Somewhere between those positions is the truth, and Japan has chosen to prepare as if the higher number is right while publishing the debate openly, which may be the most honest posture any government has ever taken toward an earthquake. And what is the fault doing right now, this summer, as I record this? Ticking, normally. The region has produced a steady run of moderate earthquakes in recent weeks, a magnitude 5.1 offshore of the Kie. Peninsula in early July, shallow, right in the Nankai zone, a magnitude 4.8 near Hyuga on the Kyushu side in late June. The same corner that triggered the 2024 advisory, a 5.7 inland of the Kii Peninsula in May, along with the usual scatter of deep events far beneath the plate. None of it has risen to the level of an evaluation meeting. None of it is abnormal for one of the most active regions on Earth, and the slow slip episodes continue their quiet rhythm under the instruments. That is the honest status, a loaded fault behaving like a loaded fault behaves for decades at a time, watched by more sensors than any piece of geology in human history. Before the close, 2 stories from the diary itself, because they explain modern Japan better than any statistic. The first comes from 1854, from the very 32-hour twin rupture we discussed, and it has a name every Japanese schoolchild knows, Inamura no Hai, the fire of the rice sheaves. When the second great shock struck the coast of Wakayama, a village headman named Hamaguchi Goryo felt the long, strange shaking, saw the sea pull back from the shore in the dusk, and understood what was coming, while his neighbors, scattered and disoriented, did not. He ran to his own fields where the year's rice harvest, his family's wealth, stood, drying in stacked sheaves, and he set them on fire. The blaze on the hilltop did exactly what he intended. The villagers, seeing the harvest burning, rushed uphill to fight the fire, and while they fought it, the tsunami came through the village below and took everything else. The fire of the rice sheaves guided the people to high ground in the dark, and the story became a textbook lesson, then a national parable, and eventually the reason the United Nations designates November 5th, the anniversary, as World Tsunami Awareness Day. One man, reading the ground and the sea correctly, spending his own fortune in 10 seconds to buy his neighbor's 10 minutes. Everything Japan has built since, the sensors, the sirens, the towers, is Hamaguchi's fire, industrialized. The second story is darker, and it explains the transparency. When the eastern Nankai segment ruptured in December 1944, magnitude 8.1, Japan was losing the Pacific War, and the government censored the earthquake. Newspapers were forbidden from reporting the scale of the destruction. Casualty figures were suppressed. Aid was minimal, because the empire could not admit weakness. Among the dead were schoolchildren mobilized to work in aircraft factories in the shaking zone, crushed in buildings whose collapse was never publicly acknowledged. When the western segment followed in 1946, the war was over, and the world finally saw. Nearly 3,000 people died across the 2 hidden earthquakes. Japan's modern culture of radical transparency about earthquake risk, the published worst-case scenarios, the drills, the advisories, the openly debated probabilities, was built consciously on the grave of that silence. When you see Japan announce to its own people that 300,000 of them could die, understand what you are looking at. It is a nation that once tried secrecy, buried its own children under it, and swore an oath. So the world watches Japan, and it should, because the Nankai Trough is a preview of questions every subduction coastline will eventually face, including, as our earlier episodes covered, the American Pacific Northwest, whose Cascadia Fault is a near twin of Nankai, similar geometry, similar magnitude, 9 potential, similar minutes to tsunami arrival, with a fraction of the preparation, no cabled seafloor network above its locked zone, far fewer evacuation structures, and a population that has never once lived through its fault's full performance. Japan's answer, so far, is the most complete civilization has produced. The seafloor is wired, the coastal towns of Kochi and Wakayama have built vertical evacuation towers, steel refuges rising above the modeled wave heights, for neighborhoods where high ground is too far. Seawalls stand where seawalls make sense, and honest signage marks where they do not. Children. In the tsunami zones, practice the run to high ground the way children elsewhere practice fire drills, and the national alert can reach every phone in the country in seconds. None of it stops the earthquake. All of it is aimed at that one number from the government's own models, the 80% of projected deaths that evacuation erases. If you live on any coastline a subduction zone can reach, Japan's rule is your rule and it fits in one line. If the shaking is strong or long, the shaking is the warning. Move up and inland immediately. Let the officials confirm later. Here is the closing thought in the quiet register. Tonight on the floor of the Philippine Sea, the cables are listening, pressure sensors in the dark, holes drilled. Into the sleeping fault, instruments wading through the years with a patience only machines and geology share, recording the slow breathing of the most documented fault on Earth as it moves through the 9th decade of its silence. 13 centuries of diary entries wait for the next line. And for the first time in all those centuries, the people living above the fault will not learn about it from the shaking or from a wave on the horizon, but from a signal racing up a fiber optic cable ahead of the sea. Whether that signal comes tomorrow or in 30 years, the entire meaning of everything you have heard tonight is that Japan intends to be mid-stride when it arrives, and that the rest of the world's coastlines are, or should be, taking notes. This channel will keep following the trough, the advisories, the slow slip science, and the quiet race between the sensors and the sea as the story develops. If something in tonight's episode stayed with you, tell me in the comments what it was. I read them all. And this community's conversations have become the best part of making these. Until next time, take care of yourselves and of the people near you. The fault keeps its diary, Japan keeps its watch.